walk into the premiere of Chris Pine's new movie.
Oh, yeah.
Oh, I didn't even read that. I just went to the numbers.
Theater is packed with almost every seat filled. If you want to estimate the number of people in the theater, you quickly count to find that there are 22 seats in the front row. And there are 25 rows in the theater. Each row appears to have one more seat than the row in front of it. How many seats are in the theater? What type of a sequence is this?
Arithmetic.
Arithmetic. It's an arithmetic sequence. Why?
Because you're adding one.
Adding one every time.
Yes.
Okay, so we're not multiplying, we're adding one every time. So the first term of the sequence would be
22.
22. The second one would be
23.
23, and there would be a grand total of how many terms? 25. So 22. So we're trying to figure out how many seats. So we would do 22 plus 23 plus 24 plus plus something. And the problem is, you kind of need to know the something. Or we need to use the other formula. Right? Because if we're doing a sum formula, remember that the sum formula is S sub, but in this case S sub 25. Why 25?
Because 25 terms.
Because there are going to be 25 terms. 25 rows, 25 terms. So S sub 25
25 over 2.
is equal to 25 over 2. And we'd love to do A sub 1 plus A sub 25. The only problem is, we don't know A sub 25. So if we don't know A sub 25, we can use the other formula and say 2A sub 1 plus n minus 1 times d. So S sub 25 equals 25 over 2 times 2 times A sub 1, which is going to be 44, plus n is 25, so 25 minus 1,
24.
and d is 1. Oh, it's 1. So like that? So 25 over 2 times 68. 2 goes to 68, 34. So 25 times 34 is 850. So what did we find out?
There's 850 seats in
There are 850 seats in the theater. Does that make sense? It's all good. Others?
31, 12,
So same page, 31. The 100th term of the sequence. So we are trying to find the specific term. No, you said 12.3, and this is 12.2. So that would be my mistake. What did we say? What number?
31.
31. Is that better? Okay. Find the sum of the finite geometric series. But thank you. I'm sorry. I did not mean that towards you. Anyway. So he's being a pain. Got it.
No, there was someone there.
There's nobody anywhere in the hallway right now, so.
He ran.
I swear there was someone.
I believe you. I'm just playing around.
Your mother saw it too.
That's why I said I.
Okay, just.
Finite, the sum of the geometric series. So S sub n equals a sub 1 times 1 minus r to the n over 1 minus r, right? Okay, so we need n and r and a sub 1. Well, I feel good about a sub 1. A sub 1 is 1/3 times 1 minus. Do you know r? What's r? R is 2. A reminder, if you're not sure what r is, take a term divided by the term before it. 2/3 divided by 1/3 is going to give us 2. So r is 2. N. 2 to the first, 2 to the second, 2 to the blah, 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 2 to the 20.
And we started at 2 to the 0.
But we started at 2 to the 0. So we went from 0, the 0th power, to the 12th power. Does that make sense? Which means, therefore, that n is n.
13.
N.
13.
Not R, N.
Oh, okay.
No, not O.
12.
I still, no. 13. Over 1 minus 2. So I can change that N to a 13. Does that make sense?
Yes. Are we have to memorize?
Okay, calculator time. Let's see. That's 10, that's 11, that's 12, that's 13, 81, 92? Check that for me to make sure that's right. That's right. That is right.
Ask it because I don't know how to explain it.
So you can throw it in the calculator, that's fine. Negative 81, 91 over negative 1. The negatives cancel, the 1 doesn't matter, which gives us 81, 91 over 3, and 19. It doesn't simplify. So that's our sum. Not too late. Did you put it up?
I don't have the paper, but I know it's fine.
What's n? N is 10. Oh. He says O a lot. Are you okay with n being 10?
Yeah, it threw me off because of that 2.
Well, it ends up being a sub 1 times r to the n minus 1. Right? So to get a power of 9, n needs to be 10.
Oh, okay.
Now I understand how we do it.
That 2 thing out because the last time I had a 2, but every other time didn't have a 2. When I see it.
Okay. So I guess what I could have done is I could have done it like our a sub n problem, our a sub n formula. A sub n is equal to a sub 1 times r, you're okay with r being 2, to the n minus 1 power. So for this power to be 12, n has to be 13. That's probably the easier way to look at it. I was trying to think too much, which always gets me in trouble.
It's a lot easier to
Is that okay?
take in.
Others?
Now that you did those 2, I understand now. So like I can go back and read.
That's cool. I heard you guys were talkative.
I got a typo.
Well,
Not like,
I got a private. I was good.
sounds like you guys were more talkative than the other honors classes.
Well, we actually put like
Now, that being said,
projector.
you're pretty much always more talkative than the other honors classes, which isn't necessarily a bad thing.
We were all the.
That's good. Yes, sir.
So on number 33, when you wrote the equation, why didn't it have a fraction like that one?
Like that one?
No, it's
Like that one?
yeah.
Because that's a sum formula. This was an a sub n formula that I wrote here. What I wrote here was a sub n equals 2 times 3 to the n minus 1.
Oh, okay. Because you had it at that. So minus.
Did I really?
Yeah. Sounds cool.
I'm sorry. How is that a mistake?
Can you do number 63? No. Oh wait, not 63, 69. I don't know. I didn't write it down. I just circled it because I knew I didn't understand.
Ah, yes. I know where we're going with this one. I'm going to tell you the problem, and then I'm not going to have to do any other part of the problem. That's my guess. The key to number 69 is, what is R? R is not 3.1.
R is 0.1.
It is not 0.031.
Okay, yeah, then I'm gone. I'm lost.
It does have a 3 and a 1 in it. So it does come from the 3.1. Say that again? 1.031. Why is that? What percent? Okay, let me ask you this. If you go to a store and you see that something is 20% off, what are you paying?
80%.
80%. Where did you get that?
You subtracted the 20%.
Why did you subtract from 100? Because 100 is where you start. So if you increase 3.1%, what are you increasing from? 100%. You hear where I'm coming from there? Does that make any sense? And you're going to see that a lot over time. You know, there's an inflation rate of 4%. So what are you going to multiply by? 1.04. Because it's inflating from 100%. So if you keep in mind that you're always starting at 100%, that takes care of it. Is that?
Yeah.
That's.
Makes sense.
The rest of it's easy. 240 times 1.031 to the 15. Okie dokie. All right. So it appears that stuff that we did on Wednesday on 12.5 was not all that difficult, because I don't think I was asked a question about 12.5
Yeah.
in any of the 3 classes. I didn't want to say it loud into the
Microphone now.
All right, so I'm going to give you the hard problems today, which really aren't all that hard. I feel confident that when we are done, you're not going to say, whoa, that was really hard. I don't think you're going to say that at all. Too. Didn't like trap it against the back and getting better. B. Sorry. All right. So, first of all, my first question is, how many terms are there going to be in our answer to this? 4. 4 terms, why 4? It's always one more than the power. Awesome, good. This looks more complex. Fair? It does. That being said, we're going to do everything, use exactly the same rules that we used on Wednesday. And if we do that, I think you're going to see that it's really not that bad at all. What do we do to figure out the first term? What's the first term? So x, well, let's take it
X
to the third,
to the third.
to the third. So the first term in our parentheses is, the first term inside the parentheses is x to the third, and the second term inside the parentheses is negative y to the third. I'm talking about in the binomial, in the original binomial. Okay? So the first term is x to the third, the second is negative y to the third. Okie dokie. So is that it for our first term?
Yes.
Yes, it is. Let's go to the second term. X to the third, 2 squared times negative y cubed to the first. Okay with that?
Yes.
No?
Oh wait, never mind.
Tell me about the next term. X to the third to the first. And the next term, negative y to the third to the third. Be careful about these. I don't think that the concept is that difficult, but the little things. So be careful with that. Is there anything else that's going to be a part of this?
The coefficient.
Coefficients. Where do we get the coefficients from? Pascal's triangle, row 3. What is row 3 of Pascal's triangle?
1, 3, 3, 1.
It's good to know.
We did this.
Don't belittle somebody because they know something.
In here? You know that's like 1, 2, 3, 4, 5. No, I'm saying like there's no like 7.
Well, there is if you kept going down rows. Row 7, row 8, row 9, etc.
Well, no, I know the rows. Never mind.
It's the triangle.
You're looking for this multi-angled pattern, and you're not going to get it. So there it is. The rest of it is all simplifying. And I agree. In my opinion, getting to here is not that bad. We just keep following the rule. That to that power, then drop it a power and raise it a power. Drop it a power, raise it a power, drop it a power, raise it a power, and then go to Pascal's triangle for coefficients. Right? So now let's simplify this. Which is it? Because I've heard x to the 6th and x to the 9th. Which is it? X to the 9th. Why?
Because 3 times 3 is 9.
When we have exponent,
Multiply.
we multiply. So that becomes x to the 9th. All right, next term.
Minus
3 times x.
Minus. Why minus?
you multiply, you get back negative.
That's a negative here, and it's a negative to the first power, which keeps it negative. Okay? So negative 3x to the 6th. The y, yeah, the negative got taken care of there. Y plus.
Because the negative is getting
It's squared. So
What's the coefficient of this y cubed, by the way? -1. So it's -1 squared, which is +1. So this is going to be a plus. Plus 3x cubed y to the 6th
Minus y to the 9.
minus
Y to the 9.
y to the 9th.
Not just that one.
That's it. That's our answer.
It's just it's not a one.
What do you think?
Pretty good.
Not too bad? Okay. So, yeah, it looked more complex, but the reality is as long as we just keep doing the rules the way that we're supposed to, it's not all that bad. Okay.
So,
Let's
So are the
do
ones that we added in the parentheses or outside of parentheses? Ones he added are in the parentheses or outside of parentheses?
the ones like these ones are already with the term, so they stay inside the parentheses. Okay.
Let's do 3 plus y to the 9th. How do you feel about 3 plus y to the 9th?
Not so bad. That's
It's
a waste of time.
Wow.
Isn't that the one that we did the other day?
We did not do the 9th power of anything.
Yeah, we did like the
It's a
fourth power.
waste of time.
It's a waste of time. It's a waste of time.
Can we perhaps phrase that differently?
It can be tedious.
It's painful.
Painful. So how many people would prefer to not do 3 plus y to the 9th? Okay, about half. So half the people want to do it and half don't want to do it?
I think it was easy.
Yeah. I feel like you told us.
No, the reality is we're not going to do 3 plus y to the 9th. I was hoping that like everybody was going to raise their hand, but most people weren't listening. So,
I was listening.
which is a bummer. You know, I had this thing all set up in my mind, but then people weren't listening, and so I just lose it all.
You know when you're rehearsing a conversation and then the person, like when you actually do it, they don't say what you said.
Oh, yeah.
That's what just
And
happened.
in this case, I'm saying, who really doesn't want to do 3 plus y to the 9th? And like 8 people raise their hands.
And again, you guys didn't raise your hands.
Maybe they're just afraid that you're gonna be like,
Well, too bad.
No, people were just talking and not really paying attention. The reality is, nobody wants to do 3 plus y to the 9th.
Oh snap! I forgot the
And we're not going to ask you to do 3 plus y to the 9th. But we are going to ask you for a specific term in 3 plus y to the 9th. And so we're going to have to find that term, and I would assume that to find one term, we are hoping that there is a shortcut way to do it without having to do the whole thing. Fair statement? Guess what? There is. They would like us to find the term that includes y to the 5th.
Find just one.
Just one term. That's all we got to find. How many terms are there, by the way?
10.
There are 10 terms. We only want to find one of them. So not too bad. Fair? Okay. So here's what we know. From doing all that stuff and things like that, to get this, we're going to have to do y to the, we're going to have to do y to the 5th, right? You're overthinking on that first part. Now, here's where you actually have to think a little bit. If we're going to do y to the 5th, then we also have to do 3 to a power. What power? To the 4th? Y to the 4th.
because
No, why did it think?
because that's
No. For what reason are you saying we should do 3 to the 4th?
it counts down by
Because the exponent here
What's that one equals 9?
plus the exponent there
Equals that
needs to add up to be
exponent
9. Did that happen over here, by the way?
there. Yes. 9. Wait, no.
Well, no,
in
it
this
happens
problem,
On the first.
it's not these numbers that need to add up to be 3. It's these numbers.
Yeah.
So here we have a second power and a first power, which become third power. And here we have a first and a second, which becomes a 3. So here we're going to do, I'm going to write this better, cleaner. 3 to the 4th, y to the 5th. Does that make sense? So we always need those exponents to add up to be the exponent up there. Is there anything else that we are going to have to deal with? Coefficient. We got to find the coefficient. Where do we usually get our coefficients? Pascal's triangle.
But we didn't
Do
do
we
it.
want to go 9 rows down?
I really don't feel like doing the nine rows of Pascal's triangle.
The NR thing.
We did something. We did that. Remember that thing? And that can give us the coefficient.
Fifth term. No?
So the top is the 9, and the bottom is always going to be the second power. So in this case, it's going to be 9, 5.
I thought it was N over R.
That's all.
So this is going to be our N, and this is going to be our R.
So R is always the second term.
So R is always the second exponent. Yep. So we have everything in line. Now we just need to crank it all out. How do we do this 9 choose 5 thing? 9 factorial over 5 factorial times 4 factorial. Remember that these two numbers will always add up to be that. So it's r factorial and then n minus r factorial goes there. Remember that? Good. How do we do that?
9 times 8.
Times 7?
Times 6 times
6
factorial.
times 5 factorial. Oh, wow. Okay. I got you. Over 5 factorial times 4 times 3 times 2 times 1. Remember what we said when we were doing this earlier in the chapter? We said that if we do it right, the top and the bottom should always have the same number of terms. So, 5 factorials go. 4 times 2 is 8. 3 goes into 6 twice. You can cancel however you want. When I'm doing it, I'm just kind of looking to see what might be easiest for me. I think in the first class, God bless you, I think in the first class I canceled the 3 with the 9. But in the second class I said, ooh, 9 times 7 and then times 2. It's easy to multiply by 2. However you want to do it is fine. Which gives us 9 times 7 is 63. 63 times 2 is 126. I just can't. I did 4 times 2 gives 8, so I canceled all 3 of them.
Oh, you could do that?
It's all multiplying and dividing, so you can cancel anything that's common. So since 4 times 2 is 8, we could have multiplied 4 times 2 and wrote 8 here, and then we could cancel the 8 and the 8. I just, you know me, I'm going to shortcut wherever I can. So 126 is our answer? No, because we still have all that gunk. Times 3 to the 4th is 81. Y to the 5th. Now do you think we're done?
No.
Why not? 126 times 81. Gotcha. It's got to be right about 10,000, doesn't it?
Hold on, bro.
10 what? 10 what? 206.
We're allowed to do that?
Multiply two numbers together? Sure.
So,
Oh, yeah. Right, you're right.
He said I was right.
Why did they even do
What are you talking about?
why do we have to?
That came from the very beginning. We were looking for the term that has y to the fifth in it. So remember, like over in here, we did this to some power. Every term had this to a power and this to a power, right? So to get y to the fifth, then we're going to have to do this to the fifth.
Oh yeah, because we can't leave it in this first row. We have to push them. Okay.
And then since we're going to do this to the, okay, shh.
And those would be our.
Since we're going to do this to the fifth,
no kidding.
then the other part of that term is going to be this to the fourth. And then we do the coefficient with it. So we have all three things. We have the coefficient, we have this to a power, and we have this to a power in every term. This is our answer.
Oh gosh.
Okie dokie. Okie dokie.
Conversation with American
Wait,
Yep.
sounds fun.
Did you want me to not erase that?
no.
Okay. I'm still waiting.
The shape of the book.
I don't know my questions.
Should we start another one and see how it goes?
Yes, but it's
Do you know your question?
Okay, I'm already lost.
You're allowed to ask it, you know.
I
Oh, let's see, how about 3x? Nah,
If you take house class, you'll be fine now.
I don't know why I just left that up there. Three x minus 5y to the 9th.
Oh, my brain.
And we are going to find the term that has y to the 7th in it. Nothing's going to change. Okay, you're going to do exactly the same thing that you have done. What you're going to see at the end is that our term is going to be much larger than you would think.
Can we get a formula sheet for this test?
Hope not.
Do we have to memorize?
Okay, so I don't know what it's going to be yet,
Okay.
but I'm going to take it one term at a time. Remember that there are three parts. There's the coefficient, there's the power of the first term, there's the power of the second term. Where do you want to start this? I would start with the power of the second term, because I want to take care of that first. I want to make sure I get this. So, what is this? How are we going to get this? So tell me what to write.
5y to the 7th.
Parentheses.
5y to the 7th.
Not 5y,
Negative.
negative 5y.
5y.
Negative 5y to the 7th power. That will get us what we want there? Okay, cool. So, we've taken care of that term. So what else are we going to have?
3y.
3x squared, because 7 plus 2 is 9. Yes? Okay with this? Negative 5y to the 7th. The reason is because we need y to the 7th. So we got to put y to the 7th. Okay? So there are our two terms. And we're always going to have this to a power and that to a power. To get this has to be to the 7th. If this is to the 7th, then this has to be to the 2nd, because these two exponents have to add up to be 9. We're okay? Okay. Is that that it? Why
Now
not?
we gotta do the thing.
Coefficient. Almost got it. What goes up? 9. What goes down?
7.
I would agree. Now we have everything. Now it's simplify time. 9 factorial, which is 9 times 8 times
7
7
factorial.
factorial over
Over 7
factorial times 2 times 1.
Yeah, and then cross those out. And
7
then-
factorials go, 2 goes into 8 4 times, which gives us 36.
Now we do 36.
So we have the 36. Yes, that's the coefficient. Now, what's next? This guy. What does that become? 9x squared.
That's 7 looking kind of scary.
That 7 does look kind of scary, especially with the 5. Then we got this guy.
Calculus.
And this, I would expect you to crank out on your calculator.
Calculator. That's what I call it.
Stole that.
Negative 78,100.
How would I do what? 5 to
It's
7?
negative 78,125.
78,125.
Yes. Yeah, negative. It should be negative.
Negative? Why negative?
The 5 is negative. It's to the odd exponent.
It's a negative number to an odd exponent, which makes it negative.
Y set.
Y to the 7.
Nope, now I get almost 5 by 36. I'm confused about the 9x.
Okay. Are you okay with this term?
Can I see this? Yeah.
What does 3x squared?
Oh, there you go. Okay, sorry.
That's a spot that people run into problems a lot, so be careful on that. Which is why I write parentheses all over the place.
You just said it really fast, like all of a sudden you went 9 squared.
Sorry. 9x. I'm sorry. That. Yep. Are we okay with it?
Yeah.
Okay. And now, 36 times 9 times negative 78,125. Negative. I feel good about negative. 2531250. That sound right?
Sure. X squared.
X squared. From there. Y to the 7th.
You just multiplied those two.
And the reality was, at the beginning of the problem, it was pretty obvious that this was going to be our answer. So, just kidding.
Of course.
Ella looked at me like, drugs?
So that's the 7th term.
It's the term that includes y to the 7th. Okay, that's all I care about. Is it the 7th term? Yeah, I guess so. I guess it would be term number 7. Because term number 1 would be a y to the 0 term. Then term number 2 would be.
So it'd be term
So I
number
guess it would be
8.
term 8. Yeah, it'd be term 8. But I don't really care what term number it is, to be honest. It has to include y to the 7th. So that's my key.
Okay, I was confused on the y to the 7th part and the y to the 5th. So
We're good?
Why is there 2 after 7 factorial?
Okay, because
never mind.
remember, like here we did 9 and 5, and the top is 9 factorial, but the bottom is 5 factorial times 4 factorial. So this one was 9 factorial over 7 factorial times, okay, and that's our 2 factorial. Okay, other questions on this? I'll do one more, and then I'm not going to do any more stuff this year.
This year.
Oh my gosh. That's only like a month though.
Not even.
x minus y squared to the 10th. We want to find the term that has y to the 8th in it. This is no more difficult. It's just a matter of making sure that you get the very first thing correct. Okay? So, which term do you want to deal with first? The y, because that's what we have to get. So, be careful.
Minus y to the second.
Minus y squared to the fourth.
Okay.
Why is it to the fourth?
4 times 2 is 8. Because Sophia's brain doesn't work.
Because y squared to the fourth is what's going to get us this y to the 8th. So you see what I mean? You just got to think it through a little bit. Once you do, it's not that bad. And then everything else is exactly the same as we've been doing it before. So we have the negative y squared to the fourth. Then over here we're going to have x
To the 6th.
to the 6th. Why is it to the 6th? Because this exponent, let's get another color for this so that I don't mess it up. This exponent plus that exponent has to equal 10. And this is the spot, hang on. This is the spot where we run into some issues sometimes. Is that people go, well, if this is y to the 8th, then that's 10, so that has to be x squared. But it's not those exponents. It's this exponent and this exponent, which have to be 10. So therefore, this exponent has to be a 6. Does that make sense? Does that make sense? Is that okay? Got it now?
Yeah.
And what? We yap a lot in here. In a couple minutes. I'll be done in like 3 minutes. Then you can yap for the rest of the time. Okay? Okay. What else? What's next? Coefficient.
This is my answer.
What's out here?
It is correct.
10.
And box it in.
Nope.
4.
Remember, it's this
Okay, my answer
guy.
is incorrect.
It's this guy.
I hope my answer's not incorrect. Okay, my answer's incorrect. So, I have a question. I know it's not like dividing, but if it helps us to like write a fraction bar to separate the numbers, can we do that, or would it confuse?
It'll probably confuse you more than it'll help you.
I'm writing a fraction.
Because if you write a fraction bar, then people are going to start trying to reduce the fraction. That would be my concern there. Are there any questions on anything we've gotten? Because every part of it, there were a couple of at least minor issues. So I want to make sure that there are no issues, minor or major, as we move on. Are there any questions on how we got any part of this? The 10-4, the 6, or the 4?
Wait, I have a question. Why don't we like simplify it so it's negative y to the 8th?
Oh, we're going to take care of that in a second.
So we don't do it yet?
Well, I mean, that's going to be my next step. But to me, the biggest part here is deciding these two
Okay, this is
exponents.
my new answer.
And so I don't want to try to shortcut it and miss the fact that that needs to be a 4. And since that's a 4, that's a 6. The shortcut part, guys, the shortcut part here has people going, well, okay, this is going to be y to the 8th. So since that's y to the 8th, that has to be a squared. That's what happens when people try to shortcut here. I don't shortcut here. Write it like this, and then remember that this power plus that power has to equal that power. Okay? All right, so now I like to do these first. So tell me what to write. 10 times 9
times 8 times 7 times 6 factorial.
times 6 factorial over 4 times 3 times 2 times 1 times
6 factorial.
6 factorial. You okay there? Go ahead, Ella.
No, it's okay.
You sure?
Yeah.
Okay.
Oh, because 6 and 4 equal 10. Okay.
Yeah, and I'm sure I should write the intermediate step here. This is 10 factorial over 4 factorial times 6 factorial. 6 factorial, 6 factorial, 4 times 2 is 8. 3 goes in at 9 3 times.
Wait, can't you just do 2 and 10?
Absolutely. But I like to keep 10s if possible because they're so easy. Do you know what I'm saying? Like if I can keep that 10 there and cancel something out, cancel something else instead, to me it makes it easier to multiply. Like I'd rather have that be a 10 than be a 5. So, and if I had turned that to a 5 and that to a 4, now I'm doing 7 times 4 times 3 times 5. As opposed to now doing 7 times 3
Which is 21.
times 10.
Which is 210.
Yeah, that seemed a lot easier to me. But that being said, cancel it however you want. Okay? I just like keeping 10s whenever possible. 210.
And bring down the
Multiply it.
X to the 6th,
Times y to the 8th.
y to the 8th.
My new answer was correct.
What happened? Where's the negative sign? Where does that
To
go?
an even power, so it disappears.
It disappears. Why?
Because it's an even power.
Because it's -1 to the 4th power, which becomes +1, which therefore means that that is our
Got any stories?
I always have stories. I'll be done. Questions on anything here, ladies and gentlemen?
I'm done.
You did?